Hello students, hope you are all well. Today we will learn about the very basic concepts on remote sensing. What is remote sensing? What does it mean? Remote sensing is the science and art of acquiring information about any object, matter or phenomenon without any physical contact with this object or matter or phenomenon under investigation. So, the most important thing is getting information without any physical contact. So, actually, we are all practicing such remote sensing process. Just remember, sitting on a place, just click on the remote and the TV is on. It is a very beautiful example and common example of remote sensing process. If we look on the picture, the solar radiation, it is the incident solar radiation from sun, and it is interacting with these superficial objects through the atmosphere. After interacting with these objects on the surface, the radiation is reflected to the satellite sensors, and it is also through the atmosphere. So in both, for the incident solar radiation and for the reflectance, there are some interactions in the atmosphere. But the important is how the process is going on. After the solar incident, the reflectance is go to the satellite sensor. It detect the reflectance and process the data to generate an electrical or photographic output. So information is gathered without any physical contact. This is an example of satellite remote sensing. Now, what are the different types of remote sensing or the remote sensor? Remote sensing is mainly two types. The first one is active remote sensing or the active remote sensor, and the passive remote sensing or the passive remote sensor. What is active and what is passive? Passive remote sensing means makes use of sensors that detect the reflected or emitted electromagnetic radiation from natural sources. And for the active remote sensing, makes use of sensors that detect the reflected responses from objects that are irradiated from artificially generated energy source such as radar. So for the active remote sensing, the sensor has its own ability to irradiate, illuminate an object, and from this object it can gather the reflectance, the information. And radar is a very beautiful and obvious example of active remote sensing. And for the passive remote sensing, it mainly uses the sensor that is able to work in the solar light. Now you can go through the detailed sensor types that is given on the table. Passive remote sensing is mainly two types, non-scanning and scanning. From non-scanning, it is also non-imaging and imaging. Camera is an example of imaging, and microwave radiometer, gravitometer, Fourier spectrum, all these are non-imaging, non-scanning, passive remote sensing example. Now the next slide shows the stages of remote sensing. When we talk about the remote sensing process, it obviously go just stay it obviously go through the stages, different stages. What are the stages? What are the important stages? Actually, remote sensing is a multidisciplinary activity which deals with the inventory, monitoring and assessment of natural resources through the analysis of data obtained by observations from a remote platform. And The important stages are: the first one, the origin of the electromagnetic radiation. Next, the transmission of this electromagnetic energy from source to target area. The third one is the interaction of this electromagnetic energy with the target. Interaction means there are some reflection, absorption, scattering, all these things are there. And the fourth is transmission of this reflected or emitted energy to the sensor. The next one is the detection of energy by sensor, converting it into photographic or electrical output. The next, transmission or recording of sensor output. Next, pre-processing of data for generation of data product. And next, the collection of the ground truth and other collateral information. It is very important, the ground truth collection is very important stage in the remote sensing. And finally, the data processing and interpretation. And all these stages are shown in this slide. Now, the next one is, what is electromagnetic radiation? What is EMR? Actually, electromagnetic radiation is the means by which the information is gathered. Clear? And for definition, it can be said that it is a form of energy. It is a form of energy that reveals its presence by the observable effects it produces when it strikes the matter. Clear? And for the electromagnetic radiation, it consists of three different fields. One is electrical field, another is magnetic field, and the third one is the direction, the speed of light. And the three different fields are perpendicular to each other. Now, the relationship between the wavelength and the frequency of the electromagnetic radiation is given there. And it clearly shows that the frequency is inversely proportional to wavelength. Clear? The speed of light, c, lambda is the wavelength, and nu is the frequency. Nu is the frequency. So the frequency is inversely proportional to the wavelength. Now, the very famous and very common and important Stephen-Boltzmann law regarding the electromagnetic radiation. What does it mean? It actually signifies the total emitted radiation from a black body. Here I want to say that all objects above absolute zero means minus 273 degree Celsius or 0 Kelvin. So all objects above absolute zero emit electromagnetic energy, including water, soil, rock, vegetation, and the surface of the sun. And the Stephen-Boltzmann law said that the total emitted radiation from a black body measured in watts per meter square is proportional to the fourth power of its absolute temperature measured in Kelvin. This is the very famous Stephen-Boltzmann law. So, the important thing to remember is that the amount of energy emitted by an object such as the sun or the earth is a function of its temperature, means absolute temperature. The greater the temperature, the greater the amount of radiant energy exiting the object. The amount of energy emitted by an object is computed by summing or integrating the area under its curve. So it is very clear from this illustration that the total emitted radiation from the 6000 Kelvin sun is far greater than that emitted by the 300 Kelvin earth. I must mention this example that the total emitted radiation from the 6000 Kelvin sun is far greater than that emitted by the 300 Kelvin earth. And next one is the Wien's displacement law. Wien's displacement, it said that the dominant wavelength from a black body is determined by its absolute temperature. Means lambda max is directly, not inversely proportional to its temperature. Means the total amount of energy exiting a theoretical black body such as the sun, we can determine its dominant wavelength based on the Wien's displacement law that is given on this equation and on this slide. So if we give an example, lambda max is equal to k divided by t. K means constant, where k is a constant equaling 2898 micrometer Kelvin and T is the absolute temperature in Kelvin. Therefore, as the sun approximates a 6000 Kelvin black body, its dominant wavelength, means the lambda max, is 0.483 micrometer. And for the earth, it is 9.66 micrometer. You can just go through this equation. Now, how the atmospheric energy matter interactions are going on means, what is scattering, what is absorption, and what is reflection, and all these things. Here we mainly concentrate on the scattering and absorption. Scattering means it differs from reflection in that the direction associated with scattering is unpredictable. So it is unpredictable. But for the reflection, the incident solar angle and the reflected angle is equal. So it can be predicted for reflection. Actually, reflecting, and actually the absorption means a process by which radiant energy is absorbed and converted into other forms of energy. Now, for scattering, there are three different types of scattering: Rayleigh scattering, Mie scattering, and non-selective scattering. For the Rayleigh scattering by gas molecules takes place in the atmosphere within 2 to 8 km above the ground. Rayleigh scattering is responsible for the blue appearance of the sky. The shorter violet and blue wavelengths are more efficiently scattered than the longer orange and red wavelengths. When we look up on a cloudless day and admire the blue sky, we are witnessing the preferential scattering of the short wavelength sunlight. And Rayleigh scattering is also responsible for red sunset. Since the atmosphere is a thin shell of gravitationally bound gas surrounding the solid Earth, sunlight must pass through a longer slant path of air at sunset or sunrise at noon. Since the violet and blue wavelengths are scattered even more during their now longer path through the air than when the sun is overhead, what we see when we look toward the sunset is the residue, the wavelengths of the sunlight that are hardly scattered away at all, especially the oranges and reds. For me, scattering, referred to as non-molecular or aerosol, takes place in the layer 4.5 km of the atmosphere where there may be many essentially spherical particles present with diameters approximately equal to the size of the wavelength of the incident energy. The actual size of the particles may range from 0.1 to 10 times of the wavelength of the incident energy. And for the non-selective scattering takes place in the lowest portion of the atmosphere where there are particles greater than 10 times of the wavelength of the incident electromagnetic radiation. Scattering actually is very important consideration in remote sensing investigations. Next one is how the interaction is going on from the source electromagnetic radiance. It comes to the surface through the atmosphere. When it comes to the atmosphere, there are many processes going on, absorption, scattering, all these things, and from the surface it is reflected to the sensor thereof, and it goes across the through the atmosphere. There are again some interactions is going on, and now the very important classification that we have already mentioned earlier: active remote sensing and passive remote sensing. Now for the active remote sensing, you can see the picture. I have actually downloaded it from internet, so I must acknowledge it is not primary photo. Now my humble submission you to just observe the picture, and this is an example of active remote sensing where they have their own lights. So this is the concept of active remote sensing. Radar, active remote sensor, because they send pulses, electromagnetic pulses, and when the pulse interact with any matter, any object on the sky or on the space, it re-reflected to them, and it can determine by calculating the distance, and it can say that there is an object. It is a very beautiful example of active remote sensing. And the example of passive remote sensing, most of the IRS group of satellites that are active on the daylight, these are the examples of passive remote sensing. So hope you will enjoy. If you have any queries, any questions, please send me to my mail. My mail address is small srkranmoy@gmail.com. Thank you very much. Stay home, stay safe.